Everyone. How are you feeling? This is the last day of the you have Friday. Which hour you have labs only on Fridays or lectures as well? Lectures or yeah. But how do they do lecture? Like it's a 2 credit course or 3 credit course? 3 and so 3 hours?
Yeah, this one like I don't know.
And do you prefer the lectures that they are 3 hours or like 2?
It's like better to do lessons.
So you have time like to absorb the information and then. And who else has on Friday in January? Also. Okay, guys. So today we start with chapter 1. What we need to understand this chapter basically, or this lecture exactly, is some basics about derivatives. If you forget some, we will write it together. At the end of this chapter, we will be able to classify and solve first order differential equations using different methods. And our objectives for today is to identify and classify differential equation and check whether a certain function is a solution of F form. But before we dive deeper, what do you expect? Like the course is differential equation. So what's a link between this course and our major? Like some of us are mechanical, electrical, and we have computer here, right? Yeah, and some of us are computer engineers. So what's a link between where we're like these differential equations, or which courses did I see differential equations? Electrical or mechanical, didn't we see it first?
Signals.
Did you saw differential equations and I remember that in the physics courses, we have like the electric circuit or the resistance or whatever, they satisfy a certain ordinary differential equation. Do you study that? Okay, anyway, this course is linked a lot to our majors, especially when you go for the advanced studies, like when you are working with your senior project or when you are doing your master, because basically in engineering we will have a certain engineering problem, right? So this engineering problems, most of the problems that they are practical problems, we try to model them in an abstract way. So when we model them, they will be satisfying a certain equation. This equation, it can be one of the options, it can be ordinary differential equation. In some places, like in business or whatever, other than ordinary differential equation, it can be an occurrence relation. So after modeling it, now what do we need to do? You're modeling a problem. Why do we model a problem? To do what for it? Solve it, right? So when I model it through a mathematical thing, I will solve this mathematical thing. The idea is that not always I will be lucky and have a solution for it, or not always this problem will have a solution. Or other things, it may be having a solution, but the solution might not be one solution. So the next step after it, which is the work of mathematicians now, after we model it and we try to find a solution using some numerical methods. The idea is that a mathematician to prove for you that this one, it has only one solution. So your work will be like valid. Otherwise, if it has more different infinite solutions or whatever, it doesn't make sense. Okay, miss? So we know now the link. And I'm sure that you will use it in your in some of your courses, even I think partial differential equation. Now we will learn like a little bit introduction to the course, introduction to the chapter, and then in the next chapter, hopefully next week, we will start solving differential equation. So our aim for today, not to solve, miss, just to understand what do we mean by differential equation, what do we mean by solution for it, and then what do we mean by initial value problem. And next week, hopefully, after doing some models and understanding the link between it and real life, we will start solving differential equations. Usually, we start with first order differential equations, and then we move. Okay, so what we need to understand for today is the types of differential equation, classifying exam according to linearity and order and solution of ODE. For those who are taking also linear algebra, you will find like it's the same. Linear, there we were talking about linear solution. Here we are talking about solution. So they are the same. But here what do we have also besides derivatives? Okay, miss? Now we said that differential equation from its name, what does it contain? Derivatives, right? An equation, it means that contains what? Variable. Does it make sense? Miss, derivatives. Can I find derivative of an apple? I need to find derivative of what? Function. Right, miss? So when we are finding derivative of a function, and this is an equation that contains derivatives, what does it mean? That the solution of it should be a function. Do we agree? Okay, perfect. Now, for differential equations, we have two types. We have the ordinary differential equation. I write it ODE for simplicity. And we have the partial differential equation. In our course, we are concerned about ordinary, but we need also to know that there is partial differential equation. We may use it in our major somewhere, and we can always get the help of mathematicians for it. Now, ordinary differential equations, it means that it contains derivatives of what? We have two types of derivatives, right? The first type of derivative, if we have function in one variable, like if I'm saying y equal x, what do you say? Y prime equal 1, let's say, right? Or dy by dx. Now, if I'm telling you z equal x plus y, can I say z prime? Z is a function in how many variables now? 2 variables. Z is a function in 2 variables. So can I say z prime? I have to specify whether I want to differentiate it with respect to x or with respect to y. So now I'm moving to something known as partial derivatives. Those who took calculus 3, they know what's meant by partial derivatives, right? So partial derivatives, it means that instead of ordinary differential equation or ordinary derivative, I'm getting partial differential equation. Okay, so this is just the difference between them. And again, in our course, we are interested in solving which types of differential equation? Ordinary differential equation. Okay, miss? Okay, give us an example of a differential equation, ordinary differential equation. So I need a function, and I need to have derivatives.
Y prime equals 5x plus 4.
Y prime equal 5x plus 4. So what's our aim here? To find y. This equation, it contains y. Our aim to find y, and it contains derivative. Another example. Yes, Dirsha?
Y prime equal 2x squared plus.
Yeah. Okay. What about if I tell you y prime plus y equals 0? Also, it is. I'm not saying here I want to solve it right now. Right now, we don't know how to solve y prime plus y equals 0. But the idea is that it satisfies this part, right? So let's look at this one. Miss, you know what's meant when we write, I usually use the two notations because if our students are using other resources or using browsing the internet, they might see instead of y prime, they may see dy by dx. Both of them are the same thing. It means the derivative of y with respect to x, which is the first derivative. When we say d squared y by dx squared, this one, what does it mean? We will use on the board both notations, okay? So in order to be familiar with it. Now this one, we have x, the independent variable, y is a function in x, y prime plus 5y equal ex. So our aim is to find y in terms of x, and it contains derivatives. So is it an ordinary differential equation or not?
Yes.
The second one, y double prime. So the second one, we can write it as y double prime minus y prime plus 6y equals 0. Also, if you look at it, y, we are finding what is a relation between the derivatives of y. And of course, our aim will be to find y. It means that it is an ordinary differential equation, right? This one an ordinary differential equation, but what are the unknown variables? X and Y. So it's okay to have more than one unknown variable. But during the first 2 chapters or 3 chapters, we will be using only when we have one unknown variable. It means that I have only like this one, and my aim is to find one.
Both of them needs to be 30.
Both of them. Of course, if they are different variables, it will not be ordinary differential equation. So this is regarding ordinary differential equation. Now, who's able to give us another example of ordinary differential equation? Yes, Abu Zaid.
Could be like the like equal x plus dy over dx minus
Okay, d cube y by dx cube, yes.
minus dy over dx
Okay,
plus y
okay.
plus 6.
This one is the same as saying what? Y triplet prime minus y prime plus y equal to 6. Again, it's a relation between the derivatives of y, so it is an ordinary differential equation. Do we agree, miss? Okay, we know what's meant by ordinary differential equation. So again, to be an ordinary differential equation, it means that the relation between y, let's say, and its derivative. It's ordinary derivatives, okay? Let's look at this one. Ut equal 3ux. And in another way, we can write it this way. Del u by del t equal 3 del square u by del x square. So this notation, when we use del, when we use d, it means that the total derivative, the ordinary derivative. When we use del, this one, what does it mean? Partial. This one, it means that the function is in how many variables? D1. Then, how many variables? More than. So how do I know whether a function is in more than one variable? If you look here, ut, I'm differentiating with respect to t, and I'm differentiating with respect to which variable also? X. So you basically here is in how many variables? X and t. If also I have uz, it means that I have x, t, and c. So this one, do I call it ordinary differential equation? What do we call it? Partial differential equation. Do I need to solve it in this course? Do I care about it in this course as solving?
Yes.
Yes.
You say yes or no?
Oh, it's ordinary differential equation. This is introduction. Many mathematicians, they work on the field of partial differential equation, and it's directly linked. Even ordinary differential equation, you have a course here that is numerical methods, right? Or numerical analysis or whatever. They are directly related to each other. So the idea of this course, the ordinary differential equation, is to get the differential equation, characterize it, and do these stuff. The idea of the numerical analysis is to find a solution for it, find a numerical solution for it. Then again, the idea of the mathematician is to prove that the solution is unique. Now, the partial differential equations, they are models for some important equations in physics. If you can search now the heat equation, the wave equation, and Laplace equation, these are modeled, all of them, they are modeled through partial differential equations. For ordinary differential equations next week, hopefully, we will do some group work related to the models of ordinary differential equation. I will send you the guidelines on Blackboard by tomorrow. Do we have any questions about the difference between them? Okay, can each of us now in front of him write his own example on an ordinary differential equation and on a partial differential equation? And put your own example. Listen, when we ask for an example, it may be much simpler than we think. Like if I'm asked about it, I will not think about y fourth prime or whatever. I will write y prime equals 0. I will choose this simplest. It's an example. So also for that, I will choose something very simple. Alex. Did you choose you? Okay, and that should be equal something. Always equal. Yeah, and here what did you choose? Okay, and really don't know variable now. Already you have the variable x and t. Yes. And here are we done? Here. Okay. So here is the change of the q and the x. Then we learn that x equal, then you will get. Like then, the I chose the variable x and y. Okay, guys, here. Did we put our examples successfully? Are we facing problems? No. Okay. Muhammad and Abdul. Okay, perfect. Now we know the difference between ordinary differential equation and partial differential equation. We will keep the partial differential equation alone, but everything that we are explaining now, it's applicable also for partial differential equation. Now, the second thing that we need to classify for an ordinary differential equation, is it linear or non-linear? What do you think when we say linearity? What do you mean? What do we mean by it?
Power ordinary. Power is ordinary.
Yeah, but the power of what? This is the point now. The power of what's our variables? In linearity, the variable is power 1, right? What's the variable that we need, or the unknown? The unknown here is what? The function that we need to find, right? So the unknown is what? Y. So everything in y, the power of it should be what? 1. For x, do I care? X is not my unknown. I don't want to find x. What do we need to find? 1. So if I have y prime, it means that I care about the y. The y prime, y double prime, and so on to be power what? Power. Okay, this tangent y is power 1. Do I accept it? Do I accept it in linearity for tangent y? Why? Because it's tangent function in y. So I don't accept it. 1 over y, do we accept it? Again, because as if it's y power negative 1. So what do we mean by linearness? It should be linear in which variables? Just in y's. Do I care about x? I can have x squared. I don't mind. Like if I have y prime equal x squared, it's still linear. But if I have y prime equal y squared, is it linear? Why? Because the power of y is 2. Okay. Let's look at the first example. Y double prime. So here, what's our function? What do we need to find here? Y. So I look at what? Y prime and y double. First, look at y double prime. Do we have a problem? Then I resume this. Please let me know now. It's okay. Do we need more zooming? Shams, we're okay with it. Y double prime. Do we have a problem in it?
No.
Y prime, it's multiplied by 3x. 3x with respect to it is nothing, right? So I'm okay with it. 9y sine x, do I care about it? Is it from this category? So this one linear or non-linear? Linear differential equation.
What about the minus 3x?
Minus 3x, we look at this at y's only.
Yeah.
So I don't care about 3x. But if I have, instead of 3x, I have 3y. 3y times y prime, now it's affected. Okay? The second one, y triple prime, do we have problem in it? Here, what do we have? Okay. Do we have the right to have sine? Sine x, yes. Sine y, can I have it? So what can we say about it? Non-linear differential equation. Okay, so as a summary for a linear nth order differential equation, all the y's and their derivatives, their power should be what? 1. Do we have the right? Just like I will go back to here, miss. So to be linear, can we have y times y prime? Let's say this one is not accepted. Can I have e power y? It's not accepted. Can we have 1 over y? Radical, let's say y prime or y. Also, all of these are not accepted. But can I have, let's say, sine x q times y? This one I can have. Okay? Okay, miss? Abdelaziz, any questions? Okay, design your own example of linear differential equation. Please, each of you design your own example of linear differential equation and raise your hand when it's done. Okay, what's your example?
5y triple prime plus y double prime plus 3y equals 3 sine x.
Perfect. So this is what? Linear differential equation. So we know what's meant by linear, what's meant by non-linear. We will still give examples on that, but now we need to talk about the order of a differential equation. Again, when we are saying differential equation, we are hearing about the variable, the function that you need to find, right? So for linearity, I look at the y's, y prime, y double prime. For the order, also we have to look for the y's. I don't care about the x. But when we say order, the order means that the highest derivative. Like your example, what was the highest derivative? Triple prime. So the highest derivative is triple prime. So what's the order? 3. Okay. Who can give us an example on first order? Y prime equal 5x. So this is what? First order. Okay, miss? So for the order, we look for what? The order of the derivative. What's the highest order of the derivative? If it's 100, it will be order 1. If it's 1, it will be order 1. Okay, miss? Abdullah, any questions, miss? Okay. Let's look at this example. Is it linear first? When we say d cube y, again by dx cube is y triple prime. So this one I would write it as this one is the same as saying x plus x y prime minus 5y equal bx. So is it linear? What's the order of it? We look at what? We have 3, we have prime, and we don't have any order. So what's the order now? This one, what's the order of it? Is it linear?
Yes.
This one is the order of 4, but is it linear? Where's the problem with the linearity? Power. Exactly. This one is, what's the order? 1, right? Is it linear? Where's the problem in the linearity? The multiplication, y times y prime, function in y times function in y, we shouldn't like, for linearity, we cannot have it. Okay, miss? This one, where is the non-linear term in f? Sin y. Does it affect the order? What's the order? Second. Did you understand the difference between linear and non-linear? Clear question? Okay, if you want to take some notes, it's not necessary to write all of these ones. I will share with you the annotation. Just like write on your own words the difference between them, and you can do your own example. Or write one of these examples.
Why doesn't the y this would be in anyone that can stand x multiplied by the y?
It's okay.
It's okay.
Yeah, because y is a function in x.
So sin y multiplied by the y, it's not okay.
Sin y alone, it's not okay.
But multiplying with the y here.
Also, it will be okay. Because whenever you are adding for the function that you want to find, you are adding a certain function, it will not be okay. Like when you say sin y, it's not okay for us because it's non-linear. It should be y alone. Yes, we will put 2 examples on the board, and you will find the order and the linearity. So the first one, miss. What's the order of it? 1. Order 1 or 100? 1. So this one, average and not derivative. Do I care about its order? So what's the highest order? So this one is first order, or you can say it's of order one. Okay? Is it linear now?
No.
Linear? This one, what can we say about it? Is it linear? This is non-linear term because we have y power 100. So with the y, it should be power 1. To make it as linear, we should remove the 100, just say y minus y.
So why is it not linear?
Y power 100. Like more, as if you are multiplying y by itself 100 times. So it's not linear. Now the second one, what's the order? Do all of us agree that this is order 3? Where is our problem? Non-linear because the tangent is linked to the y or to the y through the prime. Questions regarding linearity, non-linearity, and the order of that. Till now, we know what's the difference between ordinary differential equation, partial differential equation. We are able to define our own example on differential equation. We know also how to classify a differential equation according to the order and according to the linearity. Questions before we proceed, please? Okay. The next step, we have differential equation, but if we kept them abstractly as a differential equation, it doesn't make sense. Any equation, if we kept it as equation, it doesn't make sense unless it has what? Solution. So our first step is to understand what do we mean by a solution. And then, hopefully next week, we will learn how to solve it or how to find a solution. Just like to make sure about this course, it doesn't mean that at the end of this course, whenever you see on the street a differential equation, you will be able to solve it, okay? Or you will say that the instructor told me wrong. Not every equation we will know how to solve it. Exactly the same as calculus 2. Every integral you will know how to integrate it. So here we will learn tools, methods to help us solve a differential equation. But these methods, they will not cover all differential equations. And again, not all differential equations we are able to solve them mathematically, like by hand. Because of that, sometimes we use the numerical methods. But numerical methods, again, it's not okay alone because the numerical methods, it's fine for us solution. And if we cannot know whether it has other solutions, so we need to check from a mathematical point of view if it has only one solution or more than one solution. So that for this solution that's found by our program or our numerical methods, it will be F. Okay, miss? By solution. In general, what's meant by solution? Okay, so when someone asks you about whether this one is a solution or not, what do you do usually? Some of us substitute and some of us solve and check if they will get the same answer, right? So if I'm giving you it, what's easier to do 2 pages to solve it or just to substitute and check left equal right? So what do we mean by solution of an ODE? If we put this function inside the ODE instead of the variable, and we got left equal right, what can we deduce? It is a solution. It fits the equation. If the left is not equal to the right, what can we deduce? That it's not a solution. Does it make sense, miss? Now, before we move to the solution for ODE, let's write together the formulas for derivatives. So let's complete the tables of derivatives, okay? Because we will do it. Can we fill the table next? I'll give you 2 minutes to fill the table and then we will check it together. By C, we mean constant, okay? Constant, or we say scalar. What's the derivative of constant?
Zero.
Why is it 0?
It doesn't have a.
Just like physically, why is it 0?
It's not.
When something is constant, is there a change? Constant. So stay like that forever. And the derivative is still the rate of what changed. So when it's constant, there is no change because of that, the derivative is 0. And it becomes what? Okay, so let's write it. And x. And minus 1, then x. E radical x. E power x. Take the same sine x. And cosine x. Tangent x. And of course, we have other ones like cotangent, secant, and cosecant. But at this moment, if I need them, I will just put the formula. So this one is the table of derivatives. We can always go to it, but let's remember, in the exam, we don't give formulas. In case, let's say there is an integral that you may be forgetting it, or we do not solve something that is similar to the class, I may give just this integral as an integral. But do not expect to support you with some formulas. Other than I will keep it a little bit so that you can write it. And if you want, you can join on Teams and just take a screenshot. Done? Okay. Now, let's put some properties about derivatives. If we have addition, what do we do? If we have scalar multiplication, what do we do? If we have multiplication, and if we have this one. So the first one, we separate them, right? And this one, the k is a constant. It's what? Outside. The product rule, u prime v. V prime u or u v prime, and this one u prime v minus v prime u over v square. Now, other than this, we may use, if we have, like these ones are part of chain rule. Let's say we have e power u. And of course, if we have sine u, it's the same. Cosine u, but you will multiply it by u prime. Cosine u, it's the same. Minus sine u, and you will multiply it by u prime. When checking if something is a solution or not, it means that we will use the roots. If the order of the differential equation is 1, we will use the first derivative. If the order is 2, we'll use the second, and so on. Questions before we proceed? Now, for solutions, we can have an implicit solution and an explicit solution. Why are we playing about it in this way? Because probably next week when we start the solving differential equation, sometimes we will keep the answer in an implicit way. Any idea of what is the difference between implicit and explicit?
Explicit is it's direct. Specific. Implicit means it could be anything.
Relation. Like if you give the answer of the differential equation as y equal x or y equal tangent x, this is explicit. Y equals something in x. But if I couldn't write it in this way, let's say I wrote the solution as a relation between x and y, like x squared y plus tangent y equal to 5. So this one here, I'm not writing y in terms of x. I'm writing it as a relation between y and x. So this one we call it implicit. Sometimes I ask you to find the explicit solution because it's easy to write y in terms of x. Sometimes if I'm not specifying, it's okay just to reach the implicit. So do we know what's the difference between implicit and explicit? It's not the first time that we hear about implicit. My students in calculus 3, we talked a lot about it. And in calculus 2, I think there's something implicit differentiation, or in calculus 1, right? When the function is given as a relation, we use implicit differentiation. So what I need from you to do, what I will assume that let's look at this differential equation. Are we able to view it, or should I do more? We have this differential equation, miss, which is y prime equal x radical y. We can write it like this. We want to check if this one is a solution. Can we start with it? So here we are not asked to solve it. We are just asked to check if this one is a solution or not. By checking it, Miss, I will write that. Okay, we'll check it together. What did we get? Abdel didn't think that he got it not a solution. Who got it as solution, Miss? So what was the equation? Y prime equal x radical y. What do we need to check, Miss, here? X equals 4 over. So
60.
60. So we have a left-hand side and we have what? Work with each of them out. So this is our left-hand side and this is our right hand side. Left-hand side is what? Okay, what's y prime? This is y. Okay, give me the derivative. It's what? 4 x cubed over 16, which is basically what? X cubed over 4. Did all of us get the left-hand side in this way?
Yes.
Okay. The right-hand side is now x radical, which is x radical x4 over 16. Right, miss? This one, can we write it as x radical x4 over radical 16?
Yes.
What's radical x4? X squared over radical 16, 4. And this one is what? Did we get them the sameness?
Yes.
So what can we deduce Laplace's solution or not? It is the solution.
And then the left side.
No, we have to do always left and right. Questions regarding checking whether it's a solution or not.
How many tools we have?
How many?
Tools.
For solving? For solving later on, it depends on the order of the differential equation and on the type. For the first order, we will start separable. We have the linear, the exact, the non-exact, the homogeneous, the Bernoulli. Yeah. But they are two, they are not something like when we are practicing, when we are understanding it and practicing, we find it.
Was in calculus too. We have a lot of tools.
For integrations, yeah. This one, it's a little bit like calculus too. Okay, what I need from you to do now is, while I'm taking attendance, I will just highlight it. This is our differential equation, and we need to check whether this one is a solution or not. Please start with it. If you want to do it as first, it's okay. Ahmed is here, Noor al-Karim is here. Where is Noor? Yes. Okay, Abdulaziz is here, Sham is here, Abdurrahman al-Amiri. Muayyad. Where's Muayyad? Okay, Muhammad al-Ashqar is Muhammad here, okay? Muhammad al-Ashqar, Muhammad Hisham. No, Muhammad Hisham. Lu'ay Sulaiman. Sultan. Abdullah al-Mansuri is here, Dashan is here, Ismail here, Abu Zaid here. Johnny is here, Abdullah Islam, Abdullah Khalid, Ali, Abdullah Isawi, Ahmad al-Tayyib, Also, were we able to differentiate and check last equal to 0, right? So you're right. So again, we will have left-hand side. And we will have right. What's the right-hand side here?
0.
Okay, I'll just write it here. The left-hand side is what? Okay, y double prime minus 2y prime plus 1. So basically, what do we need, Miss? It is y double prime minus 2y prime plus 1. What do we need here, Miss? Y prime, and what do we need? Y double prime. So let's find y prime. Y is it given, Miss? This is y. Y is x dx. What's y prime?
Yes.
Okay, so x, derivative of x times dx plus dx, right? U prime v plus v prime u, right, Miss? Right? What will we get now? Derivative of x. So this is y. Done with y prime. Are we done? Do we stop here? No. What do we need to check? So y double prime, we will differentiate this one. Y double prime, derivative of ex plus derivative of x dx, right, Miss? What's the derivative of ex?
Yes.
And derivative of x dx. Already, did we find the derivative of x dx? Okay, so let's write plus ex plus x dx. We got 2ex plus x dx. So we found y double prime, we found y prime, we already have y. Where should we substitute it now? In this. Writing from the board, please check substitute, check if you will get 0. So I will wait a few minutes so that your colleagues will finish copying from the board. You need to substitute here y double prime minus 2y prime plus y. Writing from the board. So what's the last step, Miss now? Y double prime minus 2y prime plus y. Y double prime, instead of that, we will put 2ex plus x dx minus 2y prime. It was ex plus x dx, and plus y, it was x dx. What will we get now? 2ex plus x dx minus 2ex minus 2x dx plus x dx.
Yes, we go to this.
Yes. So we got it the same as the right hand side. What does it mean? Solution or not? It is a solution.
How do we do? Zeros.
These are cancelled together. Ex and XEX is 2XEX. And with this. Any questions before we proceed, Miss? We know the derivative. The antiderivative. What's the antiderivative of zero? Integral of zero. What's the integral of zero? What's the integral of zero? Just zero. Okay. So what do we mean by antiderivative? So when we say antiderivative of f is f, what does it mean? F prime is equal to f, right? So you are telling me that the antiderivative of zero is zero. It means that derivative of zero is zero, which is perfect. But what's the derivative of one? Derivative of one. Okay. So, but you told me that the antiderivative of zero is zero. Now it's one. What's the derivative of two?
0 C.
Perfect. So what's the antiderivative of zero?
C.
It's a constant. Okay. Why are we talking about antiderivative now? What did we say about the differential equation? Our aim is to do one solve, right? But a differential equation, what does it contain? Derivatives. In order to solve, basically, if I have y prime, as if I'm integrating how many times? Once. So what should I get when I integrate? Constant, right? Okay, if I have y w prime, I should integrate logically twice. So how many constants will I get? Two. If I have 100, order 100, I will integrate how many? So how many constants? So do we have only one solution for a differential equation, or it should be in terms of certain constants? So if it's first order, what should I expect? How many constants do I have? If it's second order, so we don't say solution, we say family of solutions. Okay? Does it make sense, Miss? So when we have a first order differential equation, we will have the solution in terms of a certain parameter C. If it's second order in terms of two parameters, let's say C1 and C2. No need to write it, Miss, just like the idea is to understand it, why do we have solution. And if it's order n, we will expect that we will get n constants that later we can find them. So these ones, we call them family of solutions. Okay. What do we have here? We are given a function, and we're saying that this function is a solution for this differential equation. This function, we say that it's one parameter family of solution. Why? It contains how many constants? How many constants does it contain? It contains one parameter. But why does it contain one parameter only and not two parameters? What's the order of the differential equation? The order of the differential equation is what? So because of that, we have only C. Okay, Miss? If you look here, they are telling us a particular solution is. So each value we take it for C, what would we get? Particular solution. So if you put C equals 0, we will get a particular solution. If you put C equal 1, also we will get a particular solution, and so on. Okay, Miss? Let's look at this one. Here they are telling us how many parameters do we have here? 2 parameters, right? What do you expect? What should be the order of this differential equation? Second order differential equation. Again, Miss, these ones, we will learn later on how to solve them. The idea now is just to understand. We understood what we mean by solution. Now, all these solutions, whenever we have a differential equation, logically, we should have constant, which is the constant from the antiderivative. And how many constants do we have? It depends on the order of the differential equation. Like this one, we will learn how to solve it in this equation. We will learn how to solve it in chapter 4. This one, we'll learn how to solve it in chapter 2. Okay. So if we want to take particular solution, what do we need? We need values for C1 and C2. So if you took C1 equal 1 and C2 equal 0, you will get a particular solution as EX. If you took both of them 0, you will get a particular solution as 0. Okay? And this one, what do we call it? Two-parameter family of solutions. Okay, miss? If you want to take notes about like why do we have these constants, and depending on the order we have the family of solutions, how many parameters do we have? Please write it. So again, miss, if we have fourth order, what's the parameter? How many parameters should we get? 4. And how do we get particular solutions? We get values for these constants. Do we have any questions so far? Let's read up. So we know the types of differential equations. Who will remind us types of differential equation? ODE and partial differential equation. We classify it according to linearity and order. When can we say that it's linear, Abdulaziz? Linear in what? It should be in the y's, right? Y prime, y double prime. We expect in a linear differential equation to have all the y's have what? Have 1. Then what do we mean by solution of ODE? Did we learn how to solve an ODE? Okay. So we know just what do we mean by solution. So what do we mean by solution? Substitute left equal right. In a differential equation, what do we expect to have? Solution or parameters? And the number of parameters depends on what? On the order of the differential equation. How do we know the order of the differential equation? To look at what? Highest order of what? Derivatives. Like if I have y triplet prime, the order is 3. But if I have y power 5, it doesn't mean that the order is 5. Okay, miss? Now, here we have some practice exercises. Let me just, okay, so we can go through this one if we want. Try to solve these. This one also. Try this. Okay, this one we can try it. One we can try it. Yeah, it will be already shared on Teams. I will just share it right now this on Teams. I already shared it on Teams. We are done with the part about introduction. What do we mean by differential equation, their types, classifying linearity order, what's meant by solution, and family of solution. Next, we'll talk about initial value problem, which also is the main thing that is linked to our major. So we said that usually when we solve the differential equation, we will get almost infinite solutions, right? Because we have the constants. But if I have an engineering problem, I don't want an infinite solution. So usually when we have a certain problem, there is an initial condition, the initial state that we have, right? Let's say I'm throwing a ball, right? And I want to know the velocity of it at a certain distance or at a certain time. But when I'm throwing it, I know the initial state. What's the velocity? What's the initial velocity? So whenever we have an engineering problem, we will have certain initial conditions that we know, because these ones, we know the problem, we know the initial condition. We don't care about initial condition when the initial condition, because we know it. What we care about is after a certain time, or if the variable is the temperature, at a certain temperature, what will happen, right? Right, miss? Let's say the virus, miss. At this moment, we know the virus, how let's say the spread of the virus at this moment, right? But what we care about when we do a problem or we model it, we care after 2 days or after 3 days, what will be the spread of it. So the initial condition is always there, and the initial condition is very important to determine the values of these constants. Okay, we can imagine it as indefinite integral. You'll get what? Constant, right? But when you have limits of integration, you will get constant. You will get value, I mean. Okay, man? Okay. So what's our aim? In order to understand this section, we need to understand what's meant by solution of a differential equation. Already we talked about it. And family of solutions, also we talked about it. Again, family of solution, if it's order 1, how many parameters should we have? If it's order 5, we're still in the same learning outcome, which is related to chapters 1 and 2. And our main objective is to demonstrate understanding an initial value problems, find the solution of an initial value problem, and to identify, which this one is very important, when a first order differential equation has a unique solution. Again, the uniqueness of the solution is very important. Because suppose that you did a model for a certain engineering problem and you gave it to your line manager and tell her or him that this model, it will tell us the spread of a certain virus or after a certain time. And when we see this one and we try to solve it, it has, let's say, 5 or 6 solutions. So at each time I should put in at a certain time, I will get 5 or 6 solutions. Does it make sense? So she will choose which one is correct among them. But if at each value, at each time it's giving her or him only one solution, so this one it will be applicable. Okay, miss? So the uniqueness here is very important. But first we'll start what's meant by initial value problem. Solution of S, solution of first, solution of second. Even solution of 100, it will be the same, but here we will just consider first and second. And then we'll talk about the existence and uniqueness of solution. Again, this chapter 1 is like an introduction. We still have, after this section, we have one section which is about the model. And this model, usually what I do about it, I don't explain it because I feel that it's boring to explain it. And we have lots of models. What we do is that we group ourselves into groups. Each of us will take a model and we will explain it to each other. So you will be understanding the aim of our course and you will understand your model also as well. Okay. Initial value problem, of course, we have a differential equation, but we have the initial state, right, miss? We are given the initial value problem. Let's say we are given the differential equation, y prime equal to 1. Please write in front of you, y prime equal to 1. What's the order of it, miss? So how many parameters do we expect to have? In order to find this parameter, how many equations do I need? If I have one parameter, what do I need? How many equations? One equation. So how many initial conditions do I need? One. If we wrote in front of us y double prime plus y equals 0. Y double prime plus y equals 0. What's the order of that? 2. Okay. So how many parameters will we get? 2 parameters. These 2 parameters find their solution. One equation is enough. One initial condition is enough. One initial condition, it will give me one equation. So suppose that it gave me C1 plus C2 equals 0. How will I find C1 and C2? It's infinite. So how many initial conditions do I need? 2. So in general, if it's of order 100, how many initial conditions do I need? 100 initial conditions to get 100 equations with 100 unknowns and solve them. Does it make sense, miss? So what do we mean by initial value problem? We have already a differential equation, like the one that you wrote, y prime plus y equals 0, y cubed prime minus xy equal 100 x cubed, and so on. And we have initial condition. When we say subject to, it means that the initial condition. The initial condition, they should be at a certain value. Like y, we are saying here x naught, but this x naught can be 0, can be 1, can be 2. So we should, if it is, let's say if it's y double prime minus 3y equal 2x. How many initial conditions do we need? 2. The initial condition, they should be y of something and y prime. Suppose that I want the initial condition at 1, and I will put values. Let's say here 0 and here -1. Okay? So the initial condition, if it's of second order, we should reach prime. If it's third order, we should reach third order, we should reach what? Miss second, we are reaching what? Y prime. So third, we are reaching y double prime. 100, we are reaching the 99. Okay? Why? Because we are starting as if with 0. Okay, miss? So these ones, when we say subject, we are giving the initial conditions here. This is in general how we write it. If you want to write it, write it. But even if we did not understand it in this abstract way, when we are solving, you will understand it. Do we have any questions, miss, about what do we mean by initial value problem? Okay. If it's first order, how many initial conditions? If it's second order, how many initial conditions do we need? This x naught, it doesn't stay at x naught. In real life, x naught is a value. Let's say you are talking about the heart rate. You are modeling something regarding the heart rate. So at this moment, you know the heart rate is how much, right? So let's say at time, at t equals 5. Let's say you know the heart rate. So this is the initial condition. You are taking y5 equal to something. Okay, miss? Do we have any questions before we proceed? Okay. Let's look, please do not try it now. Let's look at this example. Y equals dx, it's given. Later on in the next chapter or hopefully next week, we will learn how to find the solution. But at this moment, the family of solutions will be given because till now we don't know how to find it, right? So this one is given, the differential equation is given. But pay attention here. The initial value problems are different. Here, the initial value, we are starting with y0 equals 3, whereas in the second one, we are starting with y1 equal -2. So will we get the same answer? It's the same family of solution, but will we get the same constants? So each of them will have a certain constant. What I need for you to do is just to write the question now, and we will solve it. Why do we have here only one initial condition, miss? What's the order? 1. So how many initial conditions do we need? 1. Usually in my courses, I do extra online sessions. We don't explain anything. They are optional to attend, usually really course time. And we solve extra exercises or the online QA session. Because it's like I solve some questions, and if you have questions, you can just share them with me and we solve them together. But it's also recorded. Usually I do it. Other things that we do, I do like sometimes monthly sessions. I go to the AST and it will be just for questions and answers. You may drop by and ask your question as well. Like as if you are taking private lesson, but not like any private lesson. You are bringing some questions and you are answering them. So the first online session, which is optional, I will do it. Hopefully, I may change the date. We'll let you know if I do. We will do it on Friday, March. It will be first, yes. Friday, March 1st, and it will be again. This is optional. It doesn't mean that I can fit all your timing, but you can go through the recording, and it's not something new. We are not explaining new ideas. Just all. Okay, let's look at this one. So let's solve it together. Y prime equal y. We are already given this one. What's the condition here? Y0 equal 3, right? What do we mean by Y0 equal 3? This one, it means that x equals 0, y should be what? Does it make sense?
Yes.
Where's minus? Okay, so equals 0, y of 0 is equal to c E0. Do we agree? From where did we get this one? The function is given, right? And we are substituting x equals 0. What's E0? 1. So c times 1 is c. But also here, you are saying y equals 3, and here you are saying y equals c. So what can we deduce here? C equals 3. So did we find value for c? What will be the solution now? Is 0, this is 3, it should be 3x. Okay, miss? So the solution, it will be y equal 3x.
Why don't we take the first one, y0 and the y1?
Because these are two different ones. I will solve this one.
For the question.
Different ones. When you finish writing, think about the second one, just to make sure that we understood them. After that, do you try the second one? So the second one, do we substitute instead of x1 or 0? 1. So the initial condition doesn't mean that it should be as 0. It can be at any time that is given. So here, what do we have, miss? Y1 is equal to CE per 1, right?
Yes.
Which is D. And already Y1 is given as what? Minus 2. So compare them, what can we get? CE equal minus 2. It means that C, which is the parameter, is negative 2 over E, and all what we have to do is just substitute it. Okay, so y it will be negative 2 over E power x. We can like put the E up and get EX minus 1, but in the exam, I'm okay with this answer if you don't want to reach this one. Any questions? This one is one parameter, right? And again, why is it one parameter? Why is it one parameter, minutes?
One there.
Y prime, first term. It's those that they are not talking. Are you okay with that? You are usually calm, or because you are not understanding?
Yeah.
Usually, okay. This is anyone who is not understanding. I don't want you to tell me after 2 weeks that I don't understand on you, because we cannot change the section. And you cannot change me as well. So let me know now, okay? If there is a problem, please report it to me. If you don't want to say it in public, it's okay. Just send it to me on Teams.
The final answer is minus 3 years. Then E.
This E is minus 2 over E.
That's the thing.
Yeah, you can write it in this way and you can keep it in this way. Both of them are acceptable.
E and 3 is gone.
No, E power X. One of them is E power X and one of them is E. So we cannot remove them together.
Yes.
Do we have any questions, miss? Any questions? Okay, now let's look at this one and try to check the difference between them. How many parameters do we have here? Okay, what do we expect? What's the order? 2, right? So how many conditions do we need, miss? And we are given 2 conditions, X and X prime, which initial value 5 over 2. So can we start with this one, miss? I will just zoom it. Can we do it each 2 together just to make sure that we are understanding, miss? C1, yes. No, C1 usually we write it down. And cosine of 40. This is what we write. According to the first exam, hopefully by next week, I will share with you the time of it, so you plan ahead, just in case you want to travel or whatever. Make sure that you are not traveling. Here we have 2 parameters. How many equations should we get? 2 equations with 2 unknowns. How do we solve 2 equations with 2 unknowns, miss?
Yes.
There's the calculators.
Yeah.
Yeah, use the calculator for it. All of you know how to use the calculator to solve 2 equations with 2 unknowns or 2 equations with 3 unknowns. If you don't know, ask your colleague. Already we learned how to solve it, and already linear algebra we know methods to solve it, but we don't want to waste time in our examination or in class to solve it. So the calculator will be perfect. Five, yes. Mod 5, 1, right? Because of equation 1.
Before one man. Oh.
Okay, let's check part first. Y is equal, guys, an answer for this one. Plus D2 sine 40. We have y pi over 2 is equal to what, miss? Y pi over 2 is minus 2. And y prime pi over 2.
1.
1. Okay. Y pi over 2 is what? C1 cosine 4 pi over 2 equal negative 2, right? From where did we get this one? From brightness? Okay. Cosine 2 pi is 1, right? Sine 2 pi 0. So what will we get here? C1 is equal negative 2. We found C1. This one we don't need a calculator for it, but usually we get 2 equations to unknowns. Here we got rid of one. Now, are we done? So we give them C1 and we tell them go and find alone C2. Yeah, the idea we can do that, but the idea is that after the slide you will know that you cannot keep it in this way because if you find C1, it doesn't mean that C2 it takes us. So we have to continue. How do we continue? Which one do we need to use, miss? Y prime. So in order to use y prime, what do we need first to find? Y prime. Find y prime, miss. You have this y. Find the derivative of it. What's the derivative of this one, miss? So just like to recall together. What's the derivative of cosine u? Minus sine only or minus u prime? And sine u, what's the derivative of it, miss? U prime sine. Find the derivative now.
Start from A plus
Okay, just a second. So y prime is equal negative
sine 40
and C1 to be equal. We keep this, right?
plus the C2 sine of
Cosine, you mean 40, right? Okay. Y prime pi over 2 is given as what? Is given as 1, right, miss? Okay, substitute. What will we get? Negative 4 C1 sine 4 pi over 2 plus 4 C2 sine 4 pi over 2 is equal to what? Sine 4 pi over 2 is what? 0. What will we get? 4 C2 is equal to 1. So C2 is equal 1 over 4, right, miss? Did we get C1 and C2? Did we get C1 and C2, miss? What's the last step? Y is equal. What was C1? Minus 2 cosine 40 plus 1 over 4 sine 40.
It's probably just down.
It's already given us. Yeah, the initial condition is already given here. Y and y prime are already given. Do we have any questions, miss? Miss, if we got in the first equation C1 and C2 together, in the second C1 and C2 together, just solve it using the calculator. But it doesn't need calculator because we got rid of one of them. far? So again, in an initial value problem, we have a differential equation, but we have some initial conditions, and the number of these initial conditions is dependent on what? The number of what? The order of the differential equation. Any questions on that? Again, the main thing when we deal with partial differential equation, the partial differential equation alone, like in life, they don't make sense. They have no like importance if they are not models for certain problems. Okay, so just to solve the differential equation, it doesn't make sense. But the idea is that this differential equation is used as a model for a certain problem. So solving it means that we are solving the problem. And let's recall things. Let's say when we were talking about COVID, when we had like the first time COVID, and they started doing research about it and these stuff. So part of them, they were like interested in checking, let's say, a certain vaccine, how will it affect the virus, the spread of virus, and these stuff. So these ones, when they are studying it, they try to model it. Some of them, they modeled it using certain differential equations. Okay, I'm modeling the spread, and I want to tell the audience that this method that I did, it models it do something to COVID, so it's helpful in a certain way. Okay, so it means that it should be having the solution when they solve it, right? Because their aim is not the differential equation. These people, they care about what? About the spread, how much is spreading after taking this vaccine X or vaccine Y, it will be at a certain time, right? So if my model doesn't have solution, does it make sense? They will throw it, right? Mathematically, it's correct, but it doesn't make sense. Now, if my model, it has 100 solutions, do they care about that? So I'm giving them, it has 100 solutions, choose one of them. Also, it doesn't make sense. So the best thing for them, it will be to have how many solutions? One solution. They will not care. They don't want from you to solve it. They want from us to tell them that it has only one solution, and then using some numerical methods, some MATLAB or whatever, they can find the solution if we cannot solve it like by hand. So they are able to find an approximate value for it. And in science, you know, like there is nothing certain, it's approximation. Okay, with a certain error. This error, if it's small, it's okay for them. Okay, so the most important thing, does the problem have a solution? If yes, how many? We care about which types of solution is unique solution. What do we mean by unique solution? One solution. So if Amr, you call your name Amr, right? But usually because Amr, we call them Amr. I will call you Amr as Amr brought for me, it's modeling something about the students and brought for me a problem. And the model of the problem. And Smile also brought for me another model for it. Smile's model, it has 5 solutions, whereas Amr's model, it has only 1 solution. Which one for me, it will be effective? Amr. Okay. Do we have any questions so far? So here we are saying, does every initial value problem have a unique solution? Unfortunately. And because of that, always we care about the uniqueness of the solution and to prove and this proving cannot be done other than mathematically. Here we are giving an example on an initial value problem. Do you remember this problem? We just proved that y equal x power 4 over 16 is a solution, right? That's the initial condition. If the initial condition y of 0 equals 0, how many solutions do we have here? Under y0 equals 0, how many solutions do we have? We are saying that y equals 0 is a solution. Why? Because if we substituted it, it's true. And y equals x over 4 over 16, x over 4 over 16 is a solution. Does it mean that it has only 2 solutions? No. It means that it has at least 2 solutions. So this one, it doesn't have unique solution. Again, what do we mean by unique solution? Only one solution. So this initial value problem, it doesn't have a unique solution. Our main concern now is that we have a differential equation. How do we determine whether it has a unique solution? What we care about in this lecture is just to determine if a first order one has a unique solution. Okay? But in real life, do we care just about first order? We care about all. Because if we have something to model, it doesn't mean that I have to model it as first order. It can be second, third, or whatever. Even for partial differential equation, it's the same. So how do we determine whether it has a unique solution or not? We are talking about which types of differential equations. First order now. Y prime equals something, it's subject to a certain condition. What we need to do, we should write it first as y prime equals something, and then what do we need to do is check these. Find Fy. What do we mean by Fy? Del F by del y, or we can write it as Fy. What does it mean? Partial derivative of F with respect to y. So what do we need from this one to be continuous? What do you mean by continuous? Let's say I got, when I found del F by del y, I got 1 over y. And the interval that I'm working on, it contains 0. Is it continuous? If the interval contains 0, is it continuous? Now, if the interval that we are working on is 2 to infinity, is it continuous? Do we have problems in it? It doesn't have problem. So continuity, basically, it means that it doesn't have problem in this place, or it doesn't have. Okay, miss? Any question? If you want just to read it a little bit, and if you want to ask, we will illustrate it via the second example.
We need to be able to solve partial.
No, you will find just partial derivative. Those who did not take calculus 3 will talk briefly about partial derivatives, don't worry. Because partial derivatives, we need a little bit about it, and usually we explain it. Okay. What we read here, we will explain it here. This one, y prime equal 1. It has the same shape as this one, right? Y prime equals something. What's F here? F is equal to y, right? What's x naught here? 0. If I'm giving you y1, what's x naught? 1. Perfect. Okay. This function, f equal y, does it have problems? Does it have problem? Anything that we substitute will get a value. So it's continuous, right? What do we need also to find? F y. What do we mean by Fy? Derivative of f with respect to y. What's the derivative of y with respect to y means? 1. Do we have problem in it? So this one, it doesn't have problem, and this one, it doesn't have problem. What do we mean by this one? Our differential equation, what does it have? Unique solution. Okay, miss? Any questions? Miss, suppose that instead of y, we have 1 over y. Does it have problem or not? Yes. And where is its problem? At 0. So if I'm giving the initial condition at 0, I cannot determine if it has unique solution or not. But if I'm giving the initial condition at a number other than 0, I'm okay with it. Okay, miss? Do we have any questions so far? Any questions? If you want to take some notes, please take them. And which one? In which part, Miss Yuglas? This part? Okay. So you have this one, y prime equals something. So what's f here, Abdelaziz? In this case, what's our f? What's after the equal? Y. Y. Do you have a problem in y?
No.
So we're okay with it. It means that it's continuous. What's the derivative of y with respect to y? Derivative of y?
1.
1. Do you have problems in y? In 1? So both of them, they don't have problems. It means that you need solution.
And if I have,
You cannot determine. The idea is that we cannot determine. This one, it gives you one way. If it doesn't have problem, then you need solution. If it has problems, we cannot determine.
So this one checks if you have a solution of.
If it has, yes. It doesn't give you the solution, but it just tells you this is the unique solution. But again, miss, we don't care about finding the solution because already we can find it using MATLAB and using some numerical methods. We are able to find the solution. But the idea is that the MATLAB or numerical methods, they give us one solution. Our aim is to prove that this solution is unique. So we need to use one of our methods from differential equation. Any questions, miss? You did not take numerical methods, right? All of you are responsible to take numerical methods.
It's a 30 or 40.
Okay, so just like to recap, we are almost done with chapter 1. We have a part of chapter 1 which is about modeling. It will be done as group work. Group work in class. We will do it. We will dedicate a lecture about it. Hopefully next week we'll start by solving differential equation. Chapter 2, it will be just for first order. We have different methods, miss. We have to practice. These practice, they should be after each lecture. We should practice at least 2 questions. We can highlight them or you can choose any of them. Regarding the exam, miss, hopefully by next week, I will send you the date of it. We don't have any option other than doing it in Ramadan, but it's okay even if it's done on Ramadan. Please start preparing ahead of time. I will try to do it just during the first week of Ramadan, so you will not be like you are still be able to sleep. You will not come and sleep in the class. Okay. And what else? Yes, these are the things that we have. Everything will be announced on Blackboard. This one we did not finish it, the one that you are lost on, and hopefully next lecture we still have few slides here. So would you like me to share this one with you right now, and then I share the updated one? Oh,
What will be anatomic group as well?
this one.
Anatomic group.
The topics, chapter 1 and chapter 2. You mean for the project or for the exam? For the project, no, section 1.3. We will do the project in the class. But for the exam, chapters 1 and 2.
we have another example.
Yeah, of course, miss, but at this moment, I did not put any of that.
It will be like similar to the skill pattern.
Yeah. On Blackboard, we do it. Yes, miss?
We will do the project with MATLAB.
Project, miss, it's like to understand your model and we present it together. We will do it in class activity, miss. I will send you the guidelines on Blackboard and we will do it hopefully next week. Okay, miss, have a nice week and I'll see you hopefully next week.
It's the exam. We have to 1 and 2 and 3.
1 and